Okay, so for round robin here, we obviously need some time quantum. So let us take a time quantum of 4 here. That's a choice that we are making here. So let's take 4. Usually you'd be given that value in the examination anyway. But in case it's not given, you can take a value which is slightly lesser than the average of all the burst times here. So that is 29 by 5 is the average, which is 5. Don't take the exact average. I would suggest you to take a slightly lesser value than the average value of all the burst times. That's a choice you would generally make if it is not given in your examination. In case it is given, go by the time quantum. Okay, now time quantum here is 4. So let's start with Gantt chart again. So obviously the Gantt chart will start at time 0. At time 0, P1 is the only one which is currently available. So P1 will be scheduled first. P1 has a burst time of 10, but it would not continue till 10 because it's a preemptive version that we are working on. And in this case, this criteria that we are using is time quantum. So P1, although it likes or not, it will have to stop at 4. So while executing, it starts with taking the time quantum of 4. Now, because it has 10 burst time, it doesn't mean that it will continue till 4, but only because of the time quantum, it stops at 4. Now, which is next in line? Current time is 4. Obviously, P2 and P3 both have arrived, but P3 is first in the order. So P2 will be, it's a round robin. So similar to your first come first serve, but with a preemptive version, I would say, with a time quantum. So P2 has burst time of 7, but time quantum is only 4. So it will continue till 8. Now, mind you, every time you have to keep track of the remaining time. So P1 completed 4, that means remaining time is 6. P2 completed 4 units of time, so that means remaining time is 3. Because we have to go to the next round again. They haven't yet completed successfully. Right, so P3 is next in order. So P3 has burst time of 6, but still it will continue only for time quantum of 4, that is till 12. So the remaining time is 2. Okay. Now the current time is 12. So P4 also has arrived. So P4 will also be given a chance now. So P4 will start its execution taking time quantum of 4, but although it is given 4, I require only 1 unit of time. P4 requires only 1 unit of time to complete, burst time 1. So because I want to utilize my CPU, I don't want to keep it idle. So obviously I will release my time quantum. I require only 1 unit of time here because of the burst time here. So I will release the remaining units so that some other process can take over. So the current time is 13 now. P5 hasn't yet arrived, but I can't keep my system idle. And P4 has completed. So I will go back to P1, P2, P3 again, right? Because they have arrived earlier than this one. So again, I will start to execute P1. So P1, the remaining time is 6, but time quantum is only 4. So I will continue only till 17 and remaining time is 2 now. Now P2 requires 3 units of time, but the time quantum is 4. Although time quantum is 4, I will utilize only 3 units of time because of the remaining time what I have. So I will release the time quantum. So P2 has completed. P3 remaining time is 2. So time quantum is 4, which is okay with me because I require only 2. So I will continue only till 22 and release the time quantum. And P4 doesn't need anything. And next in line is P5. So P5, because the current time is 22, that means in the meantime P5 has also arrived. So P5, it requires 5 units of time, but the time quantum is only 4. So P5 will actually be stopped at 26 and the remaining time is 1. So 1 round is complete. Totally 2 rounds have completed so far. So I'll go back to the next round again. So in the next round, as you are able to see, P2, P3, P4 have all completed. right? What is remaining is P1 and P5, and P1 and P5 require 2 and 1 each. Time quantum is 4, which is well within the limit. So P1 will continue till 28, so there's no more left, and P5 is only 1 unit, so it will continue till 29. So that's the Gantt chart for your round robin scheduling technique. Okay, now let's go for the computations of your wait times and turnaround times. So again, as I've mentioned earlier, compute the turnaround time first using this formula. That would be easier for you to compute wait time. So turnaround time for P1, P2, P3, P4, P5, all the process you can compute using completion time minus the arrival time. So P1 completed at 28, so that would be 28 minus the arrival time is 0, which is 28. P2 completed at 20, 20 minus its arrival time is 3, which is 17, and then followed by P3. P3 completed at 22, so 22 minus its arrival time is 4, which is 18, and P4 completed at 13, so 13 minus its arrival time is 12, which is 1, and then P5 completed at 29 minus the arrival time is 18, that would be 11. So the average turnaround time, I'm sorry, the average turnaround time is sum of all this, so that would be 45 plus 18, 63, 64, and then 75 by 5, which is yeah, you can do that. And because battery is running out, so I'm not doing that. So wait time again is turnaround time minus the burst time, so that would be 28 minus 10 is equal to 18, and then 17 minus the burst time, and then 18 minus the third burst time, P3 is 6, so that is 12, then followed by 1 minus 1 is 0, and then 11 minus 5, which is equal to 6. Again, sum of all